Hello everyone. In the previous video, we talked about LLM observability and why do you need it. Here, we're going to go a little bit more technical. We're going to talk about OpenTelemetry and how to use LLM observability for OpenTelemetry. We're going to start by saying the why. Why should you trace your application with OpenTelemetry? Then we're going to discuss how to trace application with OpenTelemetry and what's in that protocol. And finally, we're going to go with an example for instrumenting an application with OpenTelemetry. Enjoy. So what is LLM observability in the traditional sense? It's three things: metrics, logs, and traces. And you will see that traces are the most important one for LLM observability. If you ever used a traditional observability platform like Datadog or New Relic, you certainly know these. Metrics compute the system state over time. For example, I have here New Relic open, and I can see the web transaction time of my API. Logs are the time-stamped strings that everybody knows and everybody has seen. It's the stuff that you get if you use printf. Now, finally, traces are the most interesting one. Traces allow us to debug an LLM application and to see the inputs and outputs of each step of it. What I have here in front of me is a trace of a chain of prompts. And you can see here that there are 3 calls for prompt 1, prompt 2, prompt 3, and under each function, there is a call for OpenAI. And I can see for each of these, the inputs, the output of the large language model, I can see the cost, the number of tokens, and more metadata. And that is extremely useful if you're building an LLM-powered application, because it allows you to see what went wrong and to debug it. But what is actually a trace under the hood? In fact, a trace is just a number, unique identifier, nothing more than that. What's interesting is what in the spans. The spans are the thing that contains the information about our trace. They have the context, which is the trace ID under which they are, and a unique span ID under that trace ID. And then they, for each one of them, have the parent. And then each one of these have attributes. And in these attributes, we save the inputs, the outputs, and even some metadata about the call. For example, which model have been used. Finally, it has events. Now, events are usually, for example, used for exceptions. And finally, they have a start time and end time. And you can see that by basically saving all these spans and providing the parent for each, we can rebuild the tree that is here so that all the spans, even in a distributed system with different kind of components, they all share the same trace ID. They all have each one its own parents and attributes, and they allow us to see this kind of global image. So we can see this, for example, here in our example. As I mentioned, here you can see each one of these is a span. And if I look at the raw data, I can see that each one of these has a starting time and end time. Each one of these has a parent, and it has attributes, basically LLM headers. The GenAI system is OpenAI. The request type is chat, and so on and so forth. The semantic convention, which is basically how we should name these attributes, allow the backend, in this case, I'm using Agenta as an LLM observability backend, to understand these attributes and show them in the right way, right? Show here stuff like the type is chat, the latency is X, and basically the inputs and outputs in a kind of beautified way. So you might have heard of OpenTelemetry. What is OpenTelemetry and how does it fit into the LLM observability landscape? The OpenTelemetry standard describes the data format of traces. For example, the fact that a trace has a context with a trace ID and span ID, has a start time, end time, attributes, what's the data format of attributes, and so on and so forth. It also specifies ways where this OpenTelemetry data need to be sent. It specifies the properties of the backend that gets it. But most importantly, it provides SDKs for instrumenting code. These SDK allows you to create traces, and that's the meaning of instrument, and send them to an OpenTelemetry compatible backend or a collector. Now, before going into the flow about how we send OpenTelemetry data and how the SDKs work, let's talk about why it's useful. The main use of OpenTelemetry is that it's vendor neutral. This means that if you instrument your code with OpenTelemetry, you can send it and swap vendors very easily. You can even send your data to multiple vendors, to multiple backends. And both the OpenTelemetry SDK and, as you will see, the collector basically take over how it's done. So how does this observability pipeline work? So you start with your code and you use the OpenTelemetry SDK to instrument your code, which is create all these traces. And then you send these traces either to a collector, and that is optional, or directly to the backend from your vendor. After you send it, then in your vendor, for example, in Agenta, you'll be able to see all these traces, to query these, to have visualization, dashboards over these, and do multiple things on them. For example, create annotations. You have also the option of using a collector. A collector is sort of a middleware where your traces go. It's very useful, especially when you have multiple services working in production, because it allows you to send all this data to the collector, and that collector will take care of batching these, of sending these to multiple backend, even to processing or filtering these, for example, sampling these. And all that configuration is in the collector, meaning you don't need to change the code of your application, for example, to switch between a vendor or another. You have all your application running, they're sending the data to the collector, and then tomorrow you want to switch vendor, you want to change the sampling rate, you can do it already from the configuration of the collector. And OpenTelemetry provides you already with default collectors that are battle tested. So here is an example application of an OpenTelemetry code in Python using the SDK. You can see that we start by setting up a trace provider, which would allow us to create or get the main object, which is a tracer that would allow us later to instrument the application. You can see here later, we basically get the tracer from our provider and then use it here with a context to create a span, and then for that span object, set the attributes. Additionally, we have a number of configuration that we can use, which is the exporter, which allows us to set which endpoints are we sending to. In this case, I'm sending the data directly to Agenta's endpoint, but I can send it first to collector and then the collector send it to Agenta. Which headers to use, in this case, an API key to send the data to Agenta. And then what span processor, and also this is configurable to send the data. And for example, you could use a simple span processor that just sends spans each time they end, or a batch span processor that batches these, and then you have the ability to decide on the batch size and all other parameters. Now, as you can see, this is a little bit complicated. If we want to instrument our agent, we don't want to go in each step of the agent and then create a span, set the attributes, and make sure that the name of the attributes fits the semantic convention of our backend. And that's where auto-instrumentation libraries come into the game. Auto-instrumentation libraries monkey patch the usually used libraries so that they integrate them with the OpenTelemetry SDK. Let me show you an example. So here, for example, I'm using the auto-instrumentation library for LangChain. And I can see I import this in the beginning, and then I call this function, which will monkey patch the LangChain library so that whenever, for example, the chunked function is called, before that, a span is created, and then when it ends, the span is ended, and all the parameters for the chat call will be saved. So basically, all what we have done manually in code with OpenTelemetry SDK, this auto-instrumentation library will do for us, which means instrumenting this code is as simple as adding this line. You don't need to deal per se with the OpenTelemetry SDK, with the parameters. We can just get started with one line. Obviously, if we want to personalize our configuration, we can still do that, for example, by changing the batching parameters or any other information. Finally, LLM observability platforms such as Agenta provide you with an SDK that makes using OpenTelemetry much easier. Basically, one layer of abstraction over OpenTelemetry that provides you with decorators that you can add to a function that automatically instrument the function and make sure that the attributes of the inputs and outputs are instrumented. It provides you with ways to change the attributes, even add annotations very easily without having to do it manually with the OpenTelemetry SDK, all while compatible with OpenTelemetry. So that's it on our introduction to LLM observability and how it relates to OpenTelemetry and observability. I hope you found that useful.